why do we use non-parametric tests? So I'm going to go through why we use them and a bit about how they work. So we've looked at tests to see if variables are associated with each other. So that was looking at correlation. And we've also looked at how you can develop models for predicting y from x, which is regression. And I also looked very briefly at if an expected proportion is true. So that was the binomial test. So how likely are you to get 2 men and 58 women in a class of 60 if there's a 1-to-1 gender ratio? It's a very unlikely event. So these are all based on probabilities. So this is just a piece of background and additional information and relates to the binomial test. So there's some things which are called combinations and permutations. So combinations are a way of selecting data from a set. Permutations are a way of arranging data in a set. If I have deal 2 hands of 5 cards, how strange is it for the first 5 to be black and the second 5 to be red? That's pretty unlikely. When I go to 7 cards, that becomes even more unlikely. But what about dealing a 1 followed by a 2 and a 3? We look for unusual patterns. When we see unusual patterns, we can say those things have a very low probability. If the probability of that specific pattern is less than 0.05, then we think that the event is significantly different from random distribution. Low probabilities are telling you about the randomness of that event. If they become very low, then you wouldn't expect that to happen by chance. So when do we use non-parametric tests? So we use the data when the data is very far from normal. So that means you've got long tails in your data and they're not symmetrical. It can be about life expectancies in cancer, for example. Earnings data, you have billionaires and very high earners. So the mean is not very similar to the median. You can also have it when you have bimodal data where you could draw the graph and use the histogram and you see 2 different peaks. Most importantly, it happens when you've got categorical data. So when you're counting data which is either nominal or ordinal, you can't have averages of this, you can't have means and standard deviations. It makes no sense to use any of the methods that you'd use for parametric data. So how do these methods work? So you make predictions about the medians of a distribution. The median's more robust than the mean, and they're based around ranking methods. Now, to be honest, you can actually use parametric versions, so of tests on very large data sets, but that's outside the scope of this particular course. The other way that they work is by using probabilities. And that's what you had in the binomial example. How likely is this really strange event, this unusual pattern, to occur? Now, the problem with non-parametric tests is they have lower power than parametric tests. So what does that mean? It means it's very hard to show that this difference did not arise by chance. It's very hard to find low probabilities. You have to have very clear evidence for you to work out that the probability of this happening by chance is small. So that means things which are called critical values are harder to satisfy, and it's much harder for you to reject the null hypothesis. So most of the time you do the experiment and you find that there's no difference between the groups, there's no relationship, there's no association. That doesn't necessarily mean that there isn't, it just means within the data set that you have here, there is no strong evidence for rejecting the null hypothesis. This can mean that you might need to go and collect bigger sets of data, or it might mean that genuinely there's no difference. But that's a question of power. So power tells you about rejecting not rejecting the null hypothesis when you should reject it.